All right, so this is the lesson on systems of linear equations. So just as a kind of an introduction to it, you're going to get questions like, is 7 comma 2 a solution to this system? So what it means to have a system of equations is you have, in this instance, two equations, two unknowns. So in order to solve anything, the number of equations has to match the number of unknowns. So in this case, our unknowns are x and y. So we have two unknowns, which means we have to have two equations. If I had three unknowns, I'd have to have three equations in order to solve them. It's just the way it works. Mathematically, it will not work if you can't match the number of variables with the number of equations. So visually, what it looks like is, let me get a pen that actually works, is if you have a coordinate system and you have two linear equations. So in this case, we have a linear equation in the green and we have a linear equation in the red. Where they cross, that is the solution. In other words, this exact point will satisfy the green equation and it will satisfy the red equation. So we're going to get into the word problems in a minute, but we have to be able to solve them. So if we're looking to find out if it's a solution, what that means is you plug this point into this equation and plug this point into this equation. It has to solve both of them perfectly. If it only solves one and not the other perfectly, then it's not a solution. So if I plug this in to this equation, I have 7 is my x, minus 2 is my y. Does that equal 5? Well, yes, it does. So it checks for that one. Now we have to plug it into here. So 2 times my x, which is 7, plus 2, which is my y. Does that equal 1? So 2 times 7 is 14. 14 plus 2 is 16. 16 does not equal 1. So this does not check, which means no, this is not a solution. It has to solve both of them perfectly, where we end up with two true statements. So I have a true statement here for the first one, a false one for the second one. So no, it does not work. And this should be a plus, that wasn't a minus sign. Okay, so if you're looking to find out if it's a solution, you are going to just plug the x and y in and see if it works. Now, there's two different ways to solve. There's actually more. But whenever we're solving, sorry, not subtraction. It's been a long day. Substitution, sorry. Okay, so substitution is one way to find out to solve a solution of, solve a system of equations. So what that means is you're finding where do the two equations cross. So if I had an equation x plus y equals 3, and I had the equation y equals 4. Okay, this is my system of equations. I know that I have a linear equation because it's x to the first, y to the first, so I know it's linear. This one is a horizontal line, so it's also linear. If I were to graph this, it would look something like this. So my y equals 4. I go to 4 on my y, and I put a horizontal line through it. This one I can use, remember the cover-up method? I cover up my x, and I find my y. So there's my y. I cover up my y, and I find my x-intercept. So where the two lines cross is this point right here. So whenever you're solving a system of equations, you're trying to find where do the two lines cross. Well, graphing works, but sometimes it's not exact. So we have to do it algebraically. So with substitution, we're literally substituting one linear equation into the other. Well, this one's already set up for us. It's already telling us to substitute 4 for y. So I take out my y and I plug in my 4, and I'm able to solve. So I subtract 4 from both sides, so I get x equals -1. So this point where the two lines cross is at -1, 4. Okay, so what I just did is I just substituted one equation into the other, and I was able to solve for my x and my y. My y was 4, my x is -1. That's the point that the two lines cross. If it's set up where it's not already set up for one variable, then you can solve it. So for instance, let's look at number 1 on page 117 in B. So my system is 2x minus y equals 0, 3x plus 5y equals 39. Oops, 39. Okay, so if I'm going to use substitution, I have to solve one or the other equation for one of the variables. Well, this is going to be the easiest one to solve for because y is already by itself. So I'm going to take this first one, and I'm going to rewrite it and then solve for y, which means I'm going to bring my 2x over by subtracting, and then plus 0 is just 0, and then I'm going to divide both sides by -1. So my y is a positive 2x. So now I can substitute that y right into there. So I have 3x plus 5 times 2x equals 39. And now I can just keep going. 3x plus 10x equals 39. I add these two. 3x plus 10x is 13x equals 39. Divide both sides by 13, and I get x equals 3. Now, remember with substitution, I want both the x and the y, because I want to know what's the one point that the two lines cross. So when x is 3, as soon as I get one of them, I can plug it into the other. So y equals 2 times 3, so y equals 6. So the solution is at the point 3, 6. And if you look at all of my writings here, it's kind of like a dance. You solve for one, you plug that one into the other, right? Make sure you don't plug it into the same one. Make sure you plug it into the other linear equation. Once I get that answer, I go back to the original where I solved. All right? So that is substitution. So let me go show you one more with substitution, and then we'll move on. All right, so we have another equation, systems of equation. We have 3x plus 2y equals 3. And we have 4x minus 5y equals -19. Now, this one, you kind of have to make a decision. Which one am I going to solve for? You can solve for x or y. It doesn't really matter. It's completely up to you. So I'm just going to take this first one and solve for x in this case. So I'm going to take this one. Here's where my dance starts. I'm going to solve for x, so I need to get rid of my y. And then I divide both sides by 3. So I get x equals 3 divided by 3 is 1. -2 divided by 3 is a -2/3 y. Okay? So that's what my x value is. So now I'm going to plug that into the other equation. So I have 4 times 1 minus 2/3 y minus 5 times y equals -19. And then I'm going to distribute this 4 through. So 4 times 1 is 4. 4 times -2/3 is a -8/3, and all I did is I'm multiplying fractions. So -8/3 y minus 5y equals -19. 4 minus, and I'm going to add these two together. Well, I have to get a common denominator. So this 5y ends up being -15/3, and all I did is I multiplied my whole number times my denominator. So -15 and 8 is a -23/3 y equals -19. Now I'm going to solve for y. So I'm going to subtract 4. I get -23/3 y equals a -23. And then I'm going to flip this over running out of room. I'm going to flip this negative 23/3 over because I'm dividing. Make sure I keep my sign. My 23's cancel. Negative times a negative is a positive. So I have y equals 3. Now I'm going to plug that back into here to find out what my x value is. So negative 2/3 times 3. So again, I can cancel my 3's. So x equals 1 minus 2, so x equals negative 1. So for this one, the solution is negative 1, 3. That is the point where these two lines cross using substitution.